We are going to talk today about how JWTs work. I'm assuming everybody can see my screen. Now, this will be a pretty quick overview of everything. JWTs, they stand for JSON Web Tokens. You may have not heard about them, in which case you'll learn a lot today. You may have heard about them and know kind of how they're used. You'll still learn a lot today. What we're going to explore here is really how they work under the hood. Not only their use case, but we're actually going to take apart a JWT and see this is what this piece of it does, this is what this piece of it does, just to give you a better idea of the technology. It's a pretty relatively, it's not a simple thing, but when you break it apart, it becomes not scary. If you've never messed with JWTs, again, JSON Web Tokens, then they might seem like this big overarching thing compared to a normal token. It's not, and I want to dispel all that today. So we'll take about 10 minutes to dig into how JWTs work. By me, I'm Aaron Krauss. I am the code boss on a bunch of social medias. I don't really use social media as much anymore, but if you see the code boss, there's a good chance it's me. I work at Clever. Clever is a software consulting company in Oklahoma City, though we work with clients nationwide, a lot of local clients in the nearby surrounding states. Really anybody, and we're software consulting. We build web applications, mobile applications, video games, AI work. Right now, we're working on a really cool 3D modeling project right now for a local client. We really do anything that people pay us to do. We're always looking for developers as well and designers. We do a lot of design in-house and other just business type things. We're about 30 people or so, and we've been around for about 10 years. So if any of that interests you and you have any, and if you want to learn more about Clever, hit me up or just Google Clever. Or if you have a company or just want to build something and want somebody to help you do that, contact Clever. So what are JWTs? So they stand for JSON Web Tokens, and that's what they are. It is a token, which is just a random string of characters that ends up breaking down into JSON, and they're used in web technologies. Bam. End of talk, right? No, let's keep going. So the full definition you'll see on their website is JWT is an open standard under RFC 7519 that defines a compact and self-contained way for securely transmitting information between parties as a JSON object. There's some fluff code in there, sure, but the big things to remember are that under the hood, it's JSON data. They are compact. You'll see some of that here in a minute. And the secure part is very important. We're going to dig into security as we go on. So how does this compare with a regular token? So historically, if you have authentication with a website, you might use token authentication. And that authentication, let's say you log in with your username and password, you get back a token. What you use that token for traditionally is to give it back to the service you're communicating with. And that service uses that token to say, okay, this token represents this user in our database, so let's give them back data that is related to this user. That's completely fine. That's how most of the web works right now. With JWTs, the token is the actual data that you're usually authenticating with. So what I mean by that is instead of saying, hey, I'm Aaron, here's my token, can you find the data that represents Aaron in your database that matches up to this token? That's not how JWTs work usually. Usually, the token itself will say, this is Aaron, he's an admin, this is an address, whatever other information you want to share, that you're actually passing that around. And if you're unfamiliar with JWTs, you're probably thinking security issues are flaring up. All that's addressed, and I think you're going to be pretty happy with how that all works. And we're going to dig into that in this talk. So JWTs are the actual data that's stored, and we're going to show in a little bit what that data actually looks like. So what are the benefits of this? The benefits are you don't need to make an extra lookup for auth or other data. Let's say I communicate with the web server and in the web server and the controller, let's say as a coder, I automatically want to get the user that I'm authenticating as. That's a pretty standard thing. With JWT, you don't need to make that database lookup because, the way JWTs are ideally supposed to work is any sort of data that you would want to capture at any point in time on a user can be stored on the token. That doesn't mean you want to store every bit of data, but some of the simple auth type stuff like name, roles, ID, those types of things, you can store those pretty easily. You can store anything on a JWT. So you don't need an extra lookup for that. And that's a pretty big one. That saves a database request for sure, at least one. If you have any join table, that saves even more. And a big one too is it makes microservice authentication easier. And there's other benefits too, but these are the ones that stand out to me. If you have a microservice application, you have to, unless you're in just a super closed environment and you're not worried about external factors, you want to authenticate requests coming from other services. And you would have to do that just like we talked about sending a token. You have to hit an authentication service to see what users does this token relate to, et cetera. It becomes more complex with microservices. What if you could just send data along that validates you as the user and everybody's okay with that? There's like, it's securely transmitted. You can guarantee that this is data that has not been corrupted. It just makes communication easier and being able to verify data between microservices. So there's plenty of tools to handle formatting JWTs for you. We're going to dig into what they actually look like, but this is not something that you have to custom architect yourself. I guarantee you in your language of choice, there's going to be tooling to support sending JWTs and handle all the formatting under the hood. They're really not formatted too crazy. We're going to dig into that today, but you don't have to worry about that. So what do they look like? This is an example JSON Web Token. It looks like a bunch of characters, right? It is a token. It's a big token. But this actually means something. Under the hood, this translates into data. You're probably wondering, where's the JSON? We'll dig into that, but the short answer is that the first two major parts of this are base 64 encoded. So if you would de-encode them, they actually are JSON. We're going to come back to this picture of the token a little bit, but let's dig in a little bit more. So before we explore what actually this is composed of, let's just talk about how you pass around the JWT. And the short answer is however you currently pass around a token. The recommendation from the JWT website is just to use your HTTP authorization header. That's pretty standard across authentication with HTTP. You can use bearer format like this. It's really up to you to implement it however you want to. Some people like to store it as cookies, HTTP only, secure cookies. That's totally fine too. However you typically store a token, it's up to you. JWT does not necessarily define that. This is just a recommendation. So digging into how the token's actually composed, it's three parts: a header, a payload, and a signature. And I'm going to bounce back a little bit. So they're all separated by periods. So this is actually the header right here. The second part is a period at the end is the payload. And this right here is the signature. So let's talk about what those actually mean. Well, the way that this works is your header stores some header information. I'll show you some more specifics of that. Payload is the actual data that you want to send and set on your JWT. And then the signature is a big piece that handles verifying that none of this information has ever been tampered with, because a token is seen on your client. It's exposed to the world. Meaning obviously you're hopefully communicating over HTTPS, but it's still anything you give to your client is exposed information that the client can mess with. So the signature handles signing the header and the payload via a hashing algorithm to verify that none of this has ever been messed with. We're going to dig a little bit deeper into that. Let's start with the header though. So they're all separated by periods. We talked about that a little bit. So they look like this: header that's encoded, payload that's encoded, and then your signature right here. So your header stores really pretty simple information. It stores the type of the token, which will always be JWT in this sense, and the signing algorithm being used for the signature. You can use SHA-256, RSA. There's plenty of other algorithms as well. So an example header payload before it's encoded looks like this. Very simple, right? You don't store any actual data in here. You would store only metadata in here. Now what happens with this header, it gets base 64 encoded, and that's it. That's the end of it. That's how we end up with that string of characters right here. Base 64 encoded header. Hopping back. The payload is actually really similar. It just stores different data. So it represents what's called claims. That's what JWT actually says that the attributes are. It says it represents claims, which is the data that you're sending. So claims are statements about an entity. Oftentimes it's user authentication, but it doesn't have to be, and additional data. So payload looks like this. And again, it looks very similar to the header. It's just a simple JSON object, but we're storing actual data in here. Now, some of these, if you've ever seen JWT before, you might see some of these look familiar. There's commonly a sub claim. Again, each of these items are called claims in JWT. There's admin is a custom one we're giving. Name is a pretty common one. When you dig deeper into JWT, there are three different types of claims you can send. You can pass as much data as you want to, but each of these conforms to a type of claim. So those three types are registered, public, and private. This is not as important in my opinion. This is just semantics over structuring your payload. In a nutshell, a registered claim is basically predefined by JWT, and they're usually very short because the idea of JWT is to be a short token. So if you ever see a claim that's like ISS, it stands for issued at, sub stands for subject, exp stands for expired at. Those are just like standardized claims that you should ideally provide in a JWT. Public is a more broad example of that. So that name claim we had in that example, that's a public claim. That's just, there's a much bigger list of the more common claims you can pass. I don't have the list here, but the last one is private, and that's just any other data. Any data that's custom to your application that you want to put in there. That's probably what most of your data is going to be. Looking back at the payload, these are actually one example of each of these types of claims. Sub here is a registered claim. It stands for subject. It's obviously a very valuable subject, I know, but that's what that stands for. Name is a more broadly defined claim. It's a public claim, and that just means it's a common claim to pass in. And then admin is a custom thing. That's not a common one. You might think it is common, but it's not defined anywhere in JWT. So this is a private claim here. But all in all, a payload is just a JSON blob of data you want to pass back. Just like the header, the payload is base64 encoded. That's how we get that middle base64 encoded string. Lastly, the signature. Signature is a little bit different. What it does is it signs the header and the payload information. And we're going to have a demo over this here in a little bit. To sign a JWT, you need the algorithm defined in the header. In that first example, I believe we are using SHA-256. You need the encoded header, you need the encoded payload, all base64 encoded, which one thing I should add is base64 encoding. If you're unfamiliar with that, it doesn't add any security. All it does is make it to where you can pass it in the URL, for example. For example, let's say you have some text that has special characters, at signs, slashes, commas. Those things you'd usually need to be escaped if you were passing them around in like a web URL. Base64 encoding, it just gets rid of all that and encodes it in a way where it's a URL passable string. So that's it. Encoded doesn't add any security. You don't need a key to decrypt it. It's not encryption. It's just makes it easy for passing it around. And then the last thing you need is secret. That's just a random set of strings that you want to sign this data with. So that's where the security comes in. You, the server, only has access to the secret, and you do not give that to the client. So you sign this data, and then if it comes back, if the data comes back and the encoded header was ever changed, the signature is not going to match up, and your server is going to know that your token was intended to be compromised. It wasn't. There's nothing that it could have done. It's you're not doing anything with that data on the client. The whole idea of a JSON Web Token is to keep data on the server. Your client ideally is not going to use data in the JavaScript in the JSON Web Token. It's strictly for the server. Okay, so an example here. This is how you would actually handle signing it. This is not real code. It probably works in some language, but this is just an idea of pseudocode, how the signature works. You take the SHA-256 hash of the encoded header, encoded payload, plus a secret at the end. And that's how you get it. I'm sorry, you encode it with a secret there. Security, by default, even though you've signed the token and encoded it, the token is visible to the client. Like if I wanted to, I could base64 decode the header, I could base64 decode the payload, and I would get that data. That's up to you if that's okay. Signing data does not make it necessarily secure. It just makes it where you can't tamper with it, so the server knows that it's the original data. I mentioned this earlier, JWTs are base64 encoded, which by default isn't secure. If you do want to make sure that the data inside of a JWT does not get modified, you can do what's called encrypting it. So these are two different processes you can do with JSON Web Tokens. This S stands for signing or signatures is one or the other. E here stands for encryption. JWS is what we're actually doing by default right now. You actually don't have to sign a JSON Web Token. It's just the most common practice to do that, and there's really no reason why you shouldn't do it. So JSON Web Signatures, we're actually doing that already. We don't need to talk about that because we've been using signatures the whole time. The E, JSON Web Encryption, we're not doing that here. So that would prevent your clients from being able to read the header information or the payload information that you're sending. Again, that's up to you and your application. You might, ideally your JSON data is going to be data about your client that they've already provided. So it's probably not the most it's probably something you don't have to hide from them. But if you add any data onto the server that you want to keep passing around that you don't want your client to get access to, then encrypting it might be a good idea. And you can do both of these. You can use signatures, you can use encryption. You don't have to use either of them, although certainly use at least one. Typically, signature is what you'll see most common, but you can do both. And remember, you don't need to reinvent the wheel. These tools for building JWTs already exist, and likely your language of choice already has a good library already. Now, I'm going to hop to a demo real quick. It's very quick. You can just go to jwt.io. It's probably the simplest website URL you'll ever type in, but you can learn a little bit more about JWTs here, JSON Web Tokens. The big thing, though, is they have this really nice debugger on their site where you can see this is what the actual JWT will look like, and here is the data that I'm passing in. So you can see this payload data right here has a similar subject and name to what I passed in before. I could add the admin, something like that in there, and then this automatically. I mean, I'm not going to say I'm not going to de-encode this to verify, but you can assume that this admin foo item in the payload got updated in this base64 encoded bit here, and you can imagine the signature was updated. But you can also type in a valid JWT that you're using, as long as you know the algorithm and how it was signed. Then you can decode it here for debugging purposes. Their website's very nice to be able to mess with this. And then if you want to learn more about it, they do have a free ebook written by Auth0, which is a pretty prominent. I guess I didn't actually know this. Looks like Auth0 may have been the ones behind JWT, or at least behind the website here. But they're pretty prominent in the authentication community. Certainly, they've got really great services. So you can download a free ebook to learn a lot more about JWTs. And to learn more, I think I just mentioned all that. In general, this is a really great technology to just, I don't want to say simplify the authentication process, because it's not really simplifying it, but to make it more powerful without making things more unreasonably complex. You're sending data to your client that your client is not intended to use, but the client has to pass it back. And you're giving this token that before really meant nothing. It was just some representation of a user. And you're giving it meaning. You're giving it like a purpose other than just representing data. It is actual data, but it's secure in that it's signed. Your client can't mess with it, and you can optionally encrypt it as well. So if you don't want the client to even see data in there, then it won't use it at all. That's all that I've got. I'm Aaron Krauss. I'm the code boss. You can go to thecodeboss.dev to see more about me. I work at Clever again. There's our website, clever.com. And lastly, I will open it up for questions.